Hello everyone, welcome to my channel, The Big Boolean Theory. This video is part of a lecture series on operating systems, and currently we are on the second module of this course, that is process management. And within this module we are trying to understand that how does the operating system manage the CPU by providing this abstraction of a process, right? And within the second module we are currently on the fourth topic, that is process system called API. So as you know, within this topic, we are looking at the system called API that is provided by the Unix operating system, to be specific. And within this API, we are looking at the set of system calls that are related to process management. So in the previous video, we talked about the different kind of operations that we as a user would want to perform on processes, right? And we also looked at what are the system calls that the Unix operating system offers to perform those operations. So now, having laid out the basic foundation in the previous video of what are the system calls that we are going to cover in this topic, let us start with the very first system call, that is the fork system call in this video. So the fork system call we will study in two parts. In this video I will give you a basic introduction, and in the next video we will take a more closer look at the system call. So without further ado, let's get started. So let us start this video by discussing the function signature of the fork system call. So this is how it looks like. So as you can see, first of all, the fork system call, it creates a new process by duplicating the calling process. So this is what the fork system call does. It is used for process creation, and the way it works is that whichever process calls this fork system call, what the fork system call would do is that it will duplicate the calling process in order to create a new one, right? And what are the arguments that the fork system call takes? As you can see, no arguments are supplied to the fork system call, right? So that is why this function signature contains this void keyword. And finally, what is the value that the fork system call returns? So it returns a value of type which is PID underscore T. So what is this PID underscore T? This is basically a type definition or an alias for an integer value, right? So essentially this fork system call returns an integer value, and basically as you can see, it is written that it returns the process ID, but there is a condition. So we will talk about the return value of the fork system call in the next video in more detail. The idea is that the fork system call returns twice. In the parent process, it returns the process ID of the child process, and it returns the second time in the child process where it returns the value of 0. Essentially, it returns an integer value, but depending on in which process it is returning, whether the parent process or the child process, the return value is different. So we will not go into detail about this. First of all, let us understand the overall functioning of the fork system call. What is this parent process, child process? How do we return twice? All of this, let us first understand that, and we will focus on the return value in the next video properly, right? So the three things that you have to take away from this slide is, first of all, what does the fork system call do? It basically creates a new process by duplicating the process that has invoked the system call, right? Second, it does not take any argument. Third, it returns a integer value, right? Now the exact details about the return value we will discuss in more detail in the next video, right? So this was the basic introduction to the function signature. So now let's see how this fork system call actually works. So for that, let us understand with an example. So here is the let's say a process A in the computer system, and this is the code of this process. There is a main function, right? And somewhere in the main function, let's assume that there is a invocation to the fork system call. So as the process is executing, it executes the instructions, and then it reaches this fork system call. And when that happens, as you know, since fork is a system call, the control will be immediately transferred to the operating system. And within the operating system's code base, there will be a routine where the code for the fork system call would be there. So this is the routine for the fork system call inside the code of operating system. So now this process A has invoked this fork system call, and the control has been transferred to the appropriate routine. So now what does the fork system call do? As we discussed, it creates a new process by duplicating the process which has invoked the system call. So the new process will be a duplicate of process A, right? So this is how it looks like. There is a process B, but as you can see, it is a duplicate of process A. The code is exactly the same. So as you can see, fork creates a copy of the original process. So that is how it creates a new process, by creating a copy, or you can say duplicating the original process. So by original process here we mean the calling process or the process which has invoked the system call, right? So now let us see some more points about this fork system call. The second point is that there exists a parent-child relationship between the calling process and the new process. So what I'm trying to say here is that process A is the parent process of process B, and process B is the child process of process A. So there exists a parent-child relationship between the process which has invoked the system call and the new process, right? Then a very important point is that the fork system call returns both in the parent and the child process. So this is a very important point, and let's spend some time understanding this. So as you can see, within the process A, which is the parent process, we invoke the system call, and it is obvious that once this routine is executed, the control will return to the instruction which follows the fork system call in process A. So this code path that you see, starting from main, then going to fork, then going to operating system and coming back, this is the obvious path, right? So the non-obvious part in this picture is that not only the fork returns in the parent process, that is process A, it also returns in the child process, and it starts, and the child process basically starts execution from the instruction which follows the fork system call. So which is the next point. As you can see, the child process starts execution by returning from fork. It does not start execution from the main. So why is this the case? Why is this peculiar form of execution? So if you see carefully, why are we starting the execution of process B from the instruction after the fork system call and not from the main? The reason is that if you start the execution of process B from the main function, starting of the main function, then what will happen? The fork system call will be again executed in process B, and again we will have some new process, let's say process C. Within the process C, again it will start from main, it will reach fork and create another process, let's say process D. And as you can see, there is an infinite chain that is being created here. Every time a new process is created and it starts from main, eventually it will reach the fork system call and again create a new process. So what was the intention of the programmer? Originally, the programmer just wanted to create one new process, right? But now if we, instead of starting execution from the instruction which follows the fork system call, if we start the execution from the main, you see what is happening. There is an infinite chain of child processes that is being created. So this is not the behavior that we wanted. So that is why the new process starts execution by returning from fork, right? It the first instruction that will be executed will be the one that follows the fork system call. And again, another thing is that if we start execution from main, then the code which precedes fork, this part I'm talking about, right? There is a piece of code which is before fork, that will be executed like obviously infinite times, because we are creating infinite number of child processes. So all of this we do not want. This is not the intended behavior. So that is why the new process that is created, it does not start from main, it starts from the instruction which follows fork. And in a way, this kind of replicates the behavior of the parent process. After the fork system call, the parent also will resume execution from the instruction which follows the fork system call. So when the process B starts from this instruction after fork system call, both of them are kind of like replicas, right? Both of them are executing the same piece of code after the fork system call. So that is how the fork system call works. It basically creates a copy of the original process, right? There is a parent child relationship between the calling process and the new process. And finally, the fork system call returns twice, once in the parent and another time in the child process. So the child process, instead of starting execution from the main function, it starts its execution from the instruction which follows the fork system call, right? So this was a basic idea of how the fork system call works. As you can see, it is a very strange kind of system call. So let's understand, let's take some examples and see the working of fork system call to understand it in more detail. So for this example, we have a very simple piece of code written in C. So as you can see, the first statement is a printf statement which prints the message hello world. And after that, we have a fork system call invocation. And then there is this, again we have another printf statement which prints a new message, that is hello again from process. And then we print an integer. So what is this integer? We print the process id of the current process, right? So we have talked about get pid in the previous video briefly. So get pid is a system call. Again, it's a very like simple system call, and what it does, as the name suggests, it returns the process id of the calling process. So let us see what is the output of this result, and analyze the output. So if you execute this piece of code, this is how the output looks like. The hello world message is printed once, and this second message that you see after the fork statement, that is printed twice. And in this integer that you see, the process ID that you see, we you can see hello again from process, and we have two distinct process IDs. One is 493 and another is 494. So before I explain the output, first of all, try yourself to understand why this kind of output was generated, right? This will help you to get a better understanding of the fork system call. So let us see why this output was generated. So first of all, when we launch this process, the execution starts from the main function, and this printf statement, the first message, that is hello world, that is printed. So this is the easy part. Then we come to the fork system call, right? When we invoke the fork system call, what will happen? What will happen is that the operating system will create a copy of the calling process, right? So we'll have two copies of this piece of code. Basically, we will have two processes which have the same piece of code. They will be copies of each other. And how will it return? The fork system call, as we discussed a while ago, returns twice. Once it returns in the parent, and another it returns in the child. In both parent and child, now the execution will resume from the instruction which follows the fork system call. So in this case, after the fork system call, the next statement is this printf statement. So now this is how it looks like. After the fork returns, we have two copies of the same process, and as you can see, both will execute from this statement, right? So this child process that is created, it does not start from main. That is one important point that you should observe. So this is what the situation looked like before we return from fork. After we return from fork, we have a new child process, and it will start execution from the statement that follows fork. And similarly, the parent will, which is obvious, resume the execution from the printf statement after the fork. So that is why we have two messages on the console. That is hello again from process is printed twice, once from the parent process and another time from the child process. The distinction between both of them can be made out from the process ID. When this statement is printed by the parent process, we have this process ID of 493. And when this statement is printed out by the child process, we have this process ID of 494, right? So that is why we have this kind of output. The hello world statement, which precedes the fork system call, will be printed once. When we have the fork system call, there will be two copies of the process, and both will basically the parent will resume execution from the statement that follows fork, and the child will start its execution from the statement that follows fork. That is why two copies of this string, that is hello again from process, will be printed. And since they are being printed from different processes, that is why the process ID is different. So this was the first example. This gives you a basic idea of how the fork system call works. So now we are going to talk about the part that how the operating system makes a copy of a process, right? So this is the crucial part. We have discussed that the fork system call creates a copy of the original process. So in this figure that you see, the process B is a copy of process A. So we haven't yet kind of discussed how does one make a copy of a process. A process is a running program. How do you copy a running program? So for that, let's get back to the basics of a process, right? So let's understand this with an example. So let's say you have process A in the computer system, right? And we know that every process in the computer system is represented by a process control block. What is a process control block? As you would recall, we talked about this in the topic of process introduction. A process control block is a data structure which contains all of the fields, all of the information that is necessary to describe a process, right? So what the operating system does is that in order to describe the process, the running program, whatever information it requires, it puts all of them in one place. That one place is this data structure, and that is what we call the process control block. And the process control block is used to represent a process. So as part of the process control block, we also have the address space, right? There are several fields in this process control block, and one of the most important ones is a pointer to the address space. So this is the process address space, right? And this is where the code and data for the program, for the process, is organized. So as you can see, the instructions for this process A, right, the code base is in this section, and all of the other pieces of data are part of the address space as well. So the entire code and data resides in the address space. So all of these things, that is the process control block, the process address space, are essential to describe the process. So when the operating system has a fork system call, what it does is that it copies the process control block. So this is how it looks like. When process A invokes the fork system call, the operating system will make a copy of its process control block. So these two are copies of each other. All of the contents of this process control block will be copied into this new PCB or process control block. And since the address space, the information about the address space is also part of the process control block, so the address space will also be copied. So everything will be copied in this way. The registers, the address space, the code, everything for process A gets copied by essentially copying the process control block, because this is the place where all of the information that is necessary to describe a running program, that is a process, resides. So when the fork system call is invoked, the operating system makes a copy of the process control block of the calling process, and that is where all of the information related to that calling process resides. So the new process has the same contents as the calling process. Now, a very important point, a small disclaimer, is that the child process is not an exact copy of the parent process. Although it is a copy, but it is not an exact copy. There are some fields, minor fields, which are different in the child process. So one of those fields is the process ID, right? So as you can see in this example, process A, the PID of process A is 100 and the PID of process B is 200. As you know, the process ID is a unique integer. It's a unique identifier which is used to distinguish between all of the processes that reside in the computer system. So that is why even if the new process is a copy of the original one, some fields like the process ID would be unique to that process. So there are minor differences, and the child process is not an exact copy of the parent process. There are certain other fields also that we will talk about in the the next video, that are different in the child process. So the point is that the child process is not an exact copy, although it's a copy, but there are some minor fields which are different in the parent and the child process. So this was a brief discussion of how the operating system makes a copy of the parent process, right? So now we will see another example of the fork system call, and see how when we copy the address space, basically when we make a copy of the calling process, how everything gets copied, the address space, and how the behavior is then influenced in the child process. So let's see this example and understand the fork system call in a more better way. So let us see the second example. Here, as you can see, this is the piece of code written again in the C language. So let's go over this piece of code. Here we have three printf statements. First one is a simple hello. And before every printf statement, I have also printed out the process ID, right? This integer that you see will basically be the process ID that we will fetch from the getPID system call. And after the initial printf statement, there is a fork system call. Then again, we have a printf statement where there's a second message that is hello again. Similarly, as you can see, I have printed the process ID here also. Then we have a computation. So basically, I have defined two integer variables, x and y. X is initialized to the value of 2 and y is initialized to the value of 3, right? These are two integer variables. After that, we have a fork system call. So in this piece of code, we have two fork system calls. In the previous example, the example one, there was just a single system call, the fork system call. Here we have two invocations of fork, right? And then we have a final printf statement where we are printing several integer values. Let's see what are those. The first one is the process ID. Then we print x, y, and the sum. We are basically doing an addition here, and here we are printing the operands and the result. So this is the piece of code. Let us see what is the output. Again, before seeing the output, I would encourage you to figure out the output on your own and then cross verify. So this small exercise will help you to like practice what you have learned. So this is how the output looks like. So basically, the first statement, that is the hello message, is printed once, and it is the process ID is 1473. It could be any process ID, but then the hello message, the second hello message, hello again, it is printed twice. And then we have for this sum that you see. the operands and the result, the values of x, y, and the result, they are printed 4 times. And here again the 4 process IDs are all different. So let us like the previous time, go over this piece of code statement by statement and understand why the output is like this, right? So let's start with the very first statement. So initially, when you launch the process, you have a single process, right? And it will start from the main function. The first statement that it will execute is the first hello message. So here the parent process, the initial process is 1473. This is the process ID of the parent, the one that you launch. So 1473 is the first process, and it prints this hello message, right? And as you can see, it is printed only once. Then we have this fork statement, and when the fork statement would return, as we discussed, there would be two copies. First of all, there will be two distinct processes, but they will be copies of each other. The process ID would be different, but they will be copies of each other. So when this fork system call returns, we will have two processes, and the execution will start basically in the child process from this printf statement, which is the hello again. So after the fork return, this is how it will look like, right? The parent will again resume the execution from this hello again statement, and the child process will start its execution here from here. So this hello that you see in the child process, this won't be executed, this fork won't be executed. The child process that is created will start its execution from this hello again, right? So that is why after 1473 we have 1474. So this 1474 is the child of 1473, and this hello again message is printed twice. The initial hello is printed only in the parent. After the fork, we have a parent and a child. So hello again is printed twice, once by the parent and once by the child. So 1473 and 1474 are the two processes that we currently have, right? Then what happens is that we reach this initialization statement where we initialize the two integer variables x and y. X is initialized to 2 and y is initialized to 3. Now the important part to understand here is that everything is copied. So the address space of the parent process will be copied into the child. So all of these data variables will be the same in both the parent and child. X will be 2 and y will be 3. Obviously this x and y, they are separate copies in separate processes. Here this is a separate process, this is a separate process, right? X and y, but the value remains the same. The memory will be different, the process will be different, but the code and the values will be the same, right? So that is why both these copies, both these processes have the same values of x and y, but these values are in distinct memory locations. That is to be understood, right? So after this initialization, again we have a fork system call. So now as you can see, this is the state of execution. When we have this fork system call, when these two system calls will return, eventually we will have four processes. This initial parent, right, this 1473 will create another process, and this 1474 will create one more. So basically this is how the execution would look like. When this parent returns, this is the child process, and when our first child process creates another child, this is how it looks like. So now we have four different processes. We started with one. After the initial fork we had two copies. After the second fork we now have four copies. And as we discussed, when we return from the fork system call, the execution will resume. In the parent it will resume from the next statement, and in the child it will start from the next statement. So these two new processes that you see here, the execution is starting from here, right? So it was, the state of execution was something like this, and after the fork return, these are the new two new child processes that have been created. And here this is the statement that will be the first one that to be executed. In these two processes, these two hello messages would not be printed, right? And x and y would already have their values, right? Because they are being forked out, right? So these statements would not be executed in these two copies. X and y are already initialized before the fork, so they all have the values of x and y, and that is why we will have four printf statements printing the message 2 plus 3 is equals to 5. You can see all of those process IDs are different: 1473, 1474, 1475, 1476. These are the four different processes that have been created. So this is how it all works, right? So we started with 1473. Basically, the process ID of the initial process was 1473. It executed the hello statement. That is why this hello message is printed once. Then it forked out and it created a child process, that is 1474. And both these processes will print this hello again. Hello would not be printed again by 1474. Then we had this initialization, that is 2 x is equals to 3, 2 and y is equals to 3. After that we forked out. So when we forked out all of these, so two new processes will be created, and in all of those four processes the values of x and y will be same. That is why finally we have this message 2 plus 3 is equals to 5 printed 4 times, right? So this is how it all works. So this was our second example. So what I'm going to do now is that explain the same piece of code that we just saw in a more pictorial way, right? So this is how I have represented the process. The same piece of code, the same statements are here, but in a more pictorial way. And by seeing this pictorial representation of work, I hope you will gain a much better understanding of the same piece of code. So let's see how this flow goes. So when you launch the process, this is how the process looks like. It has a process ID of 1473. The first statement that it executes is the hello statement, right? So that is why we have this first line of output by the process with process ID 1473, a hello statement, right? Then it executes a fork, and then we will have a child process. So this is how the child process looks like. It has a process ID of 1474, and as you can see, when the fork returns, the execution will resume from the statement hello again in 1473. And in 1474, the process with process ID 1474, the execution will begin from hello again. These two statements that I have shown in black color, they will not be executed in this process 1474, right? So now this hello again statements will be executed, right? And that is why we have this output, that these two lines that you see with 1473 and 1474, we have two hello again statements printed. Then x and y will be initialized to 2 and 3 in both of these processes. As you can see, both of these processes have the same code. So the same values will be used to initialize the data variables. Also the data, like everything is separate, right? This process is separate than this. So they have their own data, their own code, although they are copies of each other. So these 2 and 3 are present in this process, and this is a separate copy of this process, right? After the initialization of 2 and 3, that is basically x and y, both of these processes execute the fork statement. And so now we will have four processes. So as you can see, 1473 executes this fork statement, and a new child process with process ID 1475 is created. So this assignment of process ID, I have just assumed on my own. It could very well have been 1476, right? And the same goes for this process, that is 1474 executes this fork and creates this child process with process ID 1476. So this is how the relationship between all of the processes looks like. 1473 has two processes, 1474 has one process, and these two, 1475 and 1476, do not have any further child processes, right? So if you see this this process, that is the initial process, this 1473 starts from the main, starts from the very beginning of the main. That is why it gets to execute both of these fork statements, this first and this second. And that is why it has two child processes. If you look at this process 1474, it starts its execution after the first fork from this hello again. These two statements it will not execute, right? So that is why it only executes this one fork. So it has only one child process. And if you talk about these last two processes, they start their execution from this final printf statement, that is 2 plus 3 is equals to 5. They do not execute any fork statements. All of this black region that you see, they will not be executing those statements. So hence they do not create any further child processes. So finally, all of these processes will print the final statement, that is 2 plus 3 is equals to 5. And that is why you have four different statements, four different messages with the different process IDs 3, 4, 5, 6, 74, 73, 74, 75, 76. Yeah, and the order of these statements, as you can see, is not any particular order. It's not sorted in any way. So the order in which these statements will execute is decided by the scheduler. So all of these are four independent concurrent running process, right? So depending on who gets to execute on the CPU, we will have that particular order of the output. If this code is executed multiple times, you will see that the order of these statements will vary, right? So this is how the overall execution looks like. We have four processes, and there is a hierarchy. 1473 has two children, 1474 has one children, and there are two fork statements. Each process gets to execute different number of fork statements depending on where they start, and this is how the overall execution proceeds. So I hope this pictorial representation gave you a better idea of how the fork system call works, and overall that example would have been more clear, right? So finally, what I want to talk about is the man pages. So this is the final part of this video. Here, I'm going to talk about how there is a basically there is a tool in the Linux operating system. A tool, basically it's a documentation, right? Where you can go and read about the different system calls and the different commands that are there in the Unix operating system. So like we discussed at the very beginning of this video, we discussed about the signature of the fork system call in detail. So if you want to read more about these system calls or tools in Linux operating system, then you can go to the terminal. Let me show you with an example. So this is the bash terminal, and in any Linux operating system, you can write the command man. Man stands for the manual. So and then you can type in whatever you want to read. So let's say we want to get some information about the fork system call. So just write the name fork, and this gives you a documentation that you can read, right? So here you can see basically it's a Linux programmer's manual for the fork system call, the name, the signature that we just saw, description. Here everything is written in great detail, right? So all of the return values, the different arguments that it takes, everything is described properly in the Linux manual. So you can go down, it's everything is described in proper detail. So return value, the errors, right? So this is how you can read more about system calls and tools that exist on Linux. Let me show you again. If you want to read about some commands, let's say you want to read about the ls command, right? So ls is a binary, it's a command that is used to list the directory contents. So this is a user command, right? So this is how you can use the man command on the Linux operating system to gain more knowledge about your system call API and the different commands that exist on the Unix based operating system. So guys, this was it for this video. In this video, we introduced the fork system call. We discussed how it works. We also saw some different examples, right? And we discussed how a process is copied and how the new process is created, right? Finally, we discussed about the man command on Linux, where you can use that command to read more about the system calls, the tools. Basically, it's a form of documentation on the Linux OS. This was written way before the internet existed, and this is the original documentation for Linux and is very useful. So as we will discuss about the different system calls in this topic, it's a good idea that you visit that man page and read about those system calls in detail. So guys, this was it for this video. Thank you very much for watching, and I will see you in the next video. Thank you.